Right. So this is the example on page 376 in your books. First of all, you have to find the derivative. So f dash x. What's the answer? 4x cubed minus 12x squared. Alright. So that's the first step. Now the next step, the next question is find the coordinates of the stationary points. The stationary points are the turning points. So this is a turning point down here. We don't have a local maximum, do we? We have a local minimum. This is a turning point. It turns from a negative slope to a 0 to a negative slope. That's called a point of inflection. When it goes from a negative to a 0 to a negative. Or if it went the other way, if it went from a positive to a negative to a positive, that'd be another point of inflection. This is the local minimum point. So find the coordinates of the stationary points, the turning points. Right. So the second you put the derivative equal to 0. So we have 4x cubed minus 12x squared. Put it equal to 0. Alright, what can you take out of both sides? You can take x squared, hey, this way. Alright. 4x squared out of the brackets. And what's left inside? X minus 3. Okay. So first of all, you put 4x equal to 0. Is that... will anything come of that? X is equal to 0 actually. Okay, so if you look over your graph, x, that is a turning point at x equal to 0, isn't it? That's the point of inflection. So that's your first stationary point or turning point. And you have x minus 3 equal to 0. X equal to 3. At x equal to 3, that's your other turning point. Alright? So from there, how do you get your y values? You sub it into your original equation. Alright? Well, both of them. So here's your original equation. So y is equal to x to the power 4 minus 4x3. So y is equal to x to the power 4 minus 4x3. If I put x equal to 0 there, what will come out? 0 will come out. So 0 to the power 4 times 4 times 0 cubed. The answer will be y will be 0. So x is 0. You can see it, x is 0 and y is 0. Isn't that 0, 0? Isn't that the point, a turning point? Right? So that's the x and y coordinates. Now, if you look at the graph, I've already drawn it out, so we should be minus 27. So it's 3 to the power 4 minus 4 times 3 cubed. And you work that out, you'll get y is equal to minus 27. So your point is 3 comma minus 27. That's the other turning point. Okay? Right, the next bit is you've got your two turning points. Determine the nature of the stationary points. So basically, are they local maximum? Is that a local maximum? What is it? It's a local minimum. This one here is a point of inflection. So point of inflection. Alright, the nature, that's what that means. What are they? Are they a local maximum, local minimum? So how do you do that? You get the second derivative. Right, so the first derivative we got, where did we put it now? That's the, where did we put the first derivative? Yeah, here's the first derivative. Now, that's f dash x is equal to 4x cubed. So what we need to do is differentiate that again. So f dash x is equal to 4x3 minus 12x squared. Right, we have to get the second derivative. to determine the nature of the points. Like if we didn't draw a graph, which you probably won't have drawn a graph, you'll be asked to do it this way. Right, so 3 fours are 12x squared, and multiply that, you get minus 24x. Right, so what you need to do now is test the points. Test the point. So for x you put in, and here it's 0. So determine the nature. So we know it's a point of inflection, so we should get, it's a point of inflection, so the answer we should get is 0. Right. So 12 times 0 squared minus 4 times 24 times 0. Is that equal to 0? Yeah. Is equal to 0. So because it's equal to 0, it's a point of inflection. Alright. Now use the second derivative again. See? Use the second derivative. Because it's a minimum, we should get, the answer we should get is greater than 0. Alright. So write down the second derivative again and use the second point. Put 3 in. The answer we should get, it should be, well, we know the answer already, but you won't know the answer when you're doing it. So you put in 12 times 3 squared minus 24 times 3. Just quickly in the calculator, I haven't done it, would you just calculate that? So 3 squared is 9. 9 times 12, please. 9 times 12, 108, and then subtract 3 times 24. Thanks for doing that. Alright? So the answer you will get will be greater than, it will be greater than 0, won't it? When you subtract 3 times 24. So that means that because it's greater than 0, it's a second point is the local minimum. Okay? Do you understand the nature of the points? Whether they're local minimum, are they local minimum, local maximum, or are they a point of inflection? The next one, the final part of that example is find the x and y intercept on the graph. So where does the graph intersect the x-axis, and where does it intersect the y-axis? Right. So to find out where it intersects the x-axis, in this example, so what can you take out of both sides? So you use the original formula to find out how it intersects the x and y axis. So what can you take out of both sides? X cubed, and what are you left with? X minus 4, right? So right, you put that equal to 0 then. Right, so what are you left with? You're left with x cubed is equal to 0. What's x equal to? 0. X minus 4 is equal to 0. X is equal to 4. Isn't that right? Isn't that where the graph intersects the x-axis? 0 and 4. You could have got that by looking at the graph. Right, and how do you find the y values then? Sub them back in, and you should get 0, 0. So this will be 0. The y value will be 0. And you sub in 4, you should get 0. Well, they're the x values anyway.